Hey guys, how's it going? How are we tonight? We ready to do some possible rational roots theorem? Possible rational roots? Hey, some math. It's a Jimson. It's an Austin. Hey Austin, sorry I wasn't around earlier. We went on our picnic that got rained out yesterday. So we picnicked today and played some tennis. Hey September, hey Rachel. How's it going? How's your Thursday? How's the week been? Y'all got everything turned in yet? Did you do the end behavior and the graphing polynomials and the irrational roots so that tonight all you got left is some possible rational roots? Question mark, question mark. That's all we got left. Maybe, maybe. Possibly, possible. See if you can remember how to synthetically divide. It's been a while. That was like before the virus. That was so long ago. That was like back when we could go in public and stuff. Yay, way to be September, way to get it all done. Get her done, get her done. Yeah, this is kind of tricky. This is a little trickier. That's why I wanted to like rush through the first part so that tonight would be a little easier. This is a little trickier. Hey Thomas, how's it going? Losing your mind out here? You're still getting to play with kids every day or no? Did they finally shut down that daycare? Or are you still out and being essential and all that? Playing with chillins every day. We went out today to play, it's our weekly picnic. It was rained out yesterday, so we played today. And I don't know how you did it either, but you did it. You definitely did it wrong. You need to just erase it and start over. Definitely did it wrong. Because you need 3 roots, not 2 roots. I don't know what you did either. Definitely. And we went out to play tennis, and there were like we went out to the new place over on West Adams, kind of by that Walmart, and there are like 6 tennis courts out there, and they were all full. Well, we took one of them, but it was crazy. Lots of people out and about playing. Didn't I tell you what you got wrong, or no? Didn't I give you some info? Maybe not. I'll look and see. Hey, look, in Dallas in a hotel. Hey, that sounds scary. You're like not supposed to be out around people. Hey, Jacob, yay. How's it going, guys? Okay, you remember how to do synthetic? Do some synthetic. We'll talk after Austin, we'll see. I know, what are you doing traveling? Traveling. Don't you know we're supposed to be locked up in our houses? What's up with that? All right, let's see if we can remember how to do synthetic. We're going to need it for tonight. Business trip. People are still staying in hotels? I didn't realize that was still a thing. People still going out. Thought we were all locked up. But I did play tennis today. We took wipes though, and we wiped down the bench. I know people think we were weird. And even the top of the net where people might have touched it, we wiped that down before we played. We're weird. Being super safe. My dad said on Tuesday night when he came, he said that I screamed. So am I super loud to y'all, or are you just like hearing me normally? He's like, why are you screaming at your class? I told him I'm always that loud. Why are you screaming at him? Just making sure y'all can hear me. Heck, I don't know. Can't even tell. All right, I'm going to remember how to synthetically divide this. Normal volume will kick in. I'm like, they can always turn me down if they need to. If I'm too loud, they have a volume button. They can like turn it down a little bit. It's okay. It was funny. Okay, so I'm going to remember what I'm synthetically dividing. I'm dividing by x minus 2. This is the binomial I'm dividing by. But when I divide, I change this sign to be a positive. Remember that? Kind of, sort of. And then I'm going to take my coefficients. So my 1, my 5, that negative 2, and this negative 24. Drop down that 1. Good, good, good. Y'all remember. See if you can beat me to it. This way we multiply. This way we're going to add. So here we multiply first. 2. This direction we add. Here, I use a different color. This way we add. So there's 7. Multiply 14. Add 12. Multiply 24. Add 0. This is going to make us happy today when we see that 0. Check you out. You're ahead of me. Good job. So that 0 today is going to make me super happy because my remainder is 0. Do you remember, now this has been a long time ago, but we kind of touched on it when we did synthetic, that we actually find a point on our polynomial when we do this, so that this is my x value, and this is my y value. You kind of remember that? So this is going to be good today because notice when my y value is 0, isn't that a special point? Isn't this my X-Intercept? So when that remainder is 0, I'm going to be finding my X-Intercept. That's exactly right. This sign changes. So if I'm dividing by x minus 2, I make this a positive 2. If I'm dividing by x plus 2, I make that a negative 2. And remember from way back when we did it, it was because with the long division we subtracted. And this took care of by changing the sign. Now we don't have to subtract. Instead we add every time. We add every time. Cheyenne, you want to learn though. Don't leave me. You're almost there for the A. You can do it. One more week and you got the A. Think about how good that'll look. You can do it. How'd I lose you, September? We did this. It's supposed to be reviewed. This way we're multiplying. That way we add. Multiply, add. If I lost you, I'll catch you again because we're going to do more of it. It'll be okay. It'll be okay. So let me talk for a minute just about division. Let me talk about it for just a minute. For division. Yeah, Rachel, you're not allowed to leave because you got another class after this, and so therefore you have to know every little thing I teach. That's how that works. So it just needs to be positive, or we need to switch you got to switch this sign. Whatever this sign is, you switch. Whatever this sign is, you switch. So if that's a positive up here, then this becomes a negative so that we don't have to subtract, September. You switch that sign. You switch that sign. That way you're adding here and not subtracting. Because remember when we did long division, we had to subtract each time? But this way we don't have to subtract because we changed the sign to begin with. Hey, Fernando. All right, I'm better than listening to the radio anyway on your ride home. Okay, so now let's think division for just a minute. So if I've got 12 divided by 3, just some fun vocabulary. This is my divisor. This is my dividend. And this is my quotient. Okay, but importantly, notice that we say that 3 and 4 are factors of 12 because they go into 12 evenly. In other words, there's no remainder. So in this case, this x minus 2, because it has no remainder, it goes evenly into that polynomial, and therefore it is a factor of that polynomial. Just like 3 and 4 are factors of 12. If it had not gone in there evenly, if we had had a remainder, it would not be a factor of that polynomial. Then notice that I can take those two factors, this 3 times that 4, and they equal the 12. So if we come back over here to this one, and we take this factor that went in there evenly, we take that x minus 2, it's a factor, and if I multiply it times the quotient, do you remember how to do the quotient? We go down 1 degree. So this was x cubed, so that one's going to be x squared. That's a positive number, so I put a plus. I just count down now, 2, 1, 0. So the quotient here is x squared plus 7x plus 12. If I were to multiply this times that, I would get this polynomial. So this is a factor and this is a factor of that polynomial. Just like 3 and 4 are factors of 12. But they're only factors if we don't have a remainder. So 3 goes in there evenly. This binomial goes in there evenly because it doesn't have a remainder. So it is a factor. Okay, so that's kind of a big deal. Now, I haven't factored that down to linear form, like not linear terms, because that one's still quadratic. I can factor this fully so that I have x minus 2, use the AC method now. A is 1, C is 12. Factors of 12 that add to 7 are 3 and 4. So x plus 3 and x plus 4. Now it is factored completely. Boom. So by knowing one of the factors, I was able to factor it completely down to linear terms. So we're going to do this today, where remember when our two things don't match and we cry? Sometimes we have to use this synthetic division to help us get one factor, and then that helps us to get our other factors so that we can find our X-intercepts. So we're going to use synthetic today to help us to factor it. All right, so let's do some. Let's graph a polynomial, fully and completely and totally. Did I forget the haiku again? Oh well. Did I forget that last on Tuesday also? I think I forgot on Tuesday also. Oh well. His haiku today was really dark anyway. It wouldn't have been uplifting. Maybe that's why I forgot it. All right, so let's do this. We're going to graph this polynomial. And you guys have gotten really good at graphing the polynomials. I've seen lots of great graphs. I've seen lots of good videos. I've got a couple of videos out already, and they were good. Y'all did a good job with the videos. Y'all go watch your videos afterwards. Make sure that you've actually done what you said you were going to do. And it sounds all right. But most of y'all have been really good. All right, so how do we start? Oh yeah, in behavior. So my leading coefficient is 1. I care about the 1, the fact that it is positive. It's positive. That's what I care about it. Be sure and put that when you're turning in your stuff. I need to know that because it's positive, it tells me what's happening on the right. Good. Good, September, it rises on the right. Perfect. It's positive, so it rises on the right. Now, my dope is 3. What do I care about that 3? What are you going to tell me on your work? What do we care about that 3? How do we know what it's doing? Well, it's odd. Also, when you tell me it's odd, tell me it's the opposite. Good, September, it's the opposite. Don't forget that opposite. That odd means opposite in behavior. If you put even, then you got to tell me it's the same. Don't leave that off. Then that tells me what's happening on the left. Since it's opposite of rising, it's going to fall. Now, my dope is 3. So I know there are 3 roots. And my dope is 3. So that tells me that there are 2 terms. By the way, if it tells you that there are 3 roots, when you get ready to do your factors, you better have 3 factors. When you tell me how many X-intercepts you have, because all our X-intercepts are going to be real, you better have that many X-intercepts. So that's what that means. Check yourself with it. Okay, then I got a sketch. Well, it's rising on the right. It's falling on the left. I got 2 turns. 1, 2. So it should look like something like that at the end. If it doesn't look like that, nice, smooth, and continuous, then we go, hey, I did something wrong. All right, now what? Oh, now we look for the Y-intercept. And to find that Y-intercept, x equals 0. So I just plug in my 0 for x. So my Y-intercept is at 0, 30. What? Okay, great. Y'all are old hat at this. You totally got this now, right? Now I'm going to find my X-intercepts. This is what we're here for tonight. This is going to be the fun part tonight. So y equals 0. Remember that Y-intercept. You're not going to tell Jimson that it's 30. Don't you do it. Don't you tell him it's 30. What is the Y-intercept? Is a point at 0, 30. Make sure you give him the point. So far, Jimson, everything I've seen turned in has been pristine. It's been so pretty. I've been so impressed. They're giving me words like this and explanations. They're telling me every little detail, and I've only seen points. I've been so impressed. Best class ever. They all need to take pre-cal. Okay, so now I'm going to set it equal to 0 and solve. And our favorite part, when we solve, we F this thing. So I'm going to F it. I'm going to factor it. Look at the first two. Look at the last two. Oh, first thing I look for is greatest common factor. Slow down, Miss Simpson. Just slow down. No hurries. No hurries. F it. F it. No greatest common factor. So then we go, well, then what? Well, there are 4 terms, 1, 2, 3, 4, so I'm going to group them. I'm going to put the first 2 and the last 2 together. First 2 comes out as an x squared. Leaves me with x minus 6. Second one, a negative 1, comes out and it leaves me with x minus 30. What do you see? What do you see? Do those two match? We said all along we got all happy when they matched. They don't match this time. That means that we cannot factor that out. This doesn't work to factor by grouping. When they don't match, we can't do it by grouping. We can't do difference of squares either because, well, the x minus 1, if we could factor something out, that x minus 1 might be factored by squares, but these two didn't match, so we can't factor that out. I'm crying too, Austin. I know there's no crying in math, but we got this. We can do it. So here's what we're going to do. Instead, how do we go? Instead, we pull ourselves together and we're going to use synthetic division to help us. So like we did earlier, we're going to take a factor and we're going to divide. And if it goes in there evenly, then we're going to be factoring. Now, Thomas, we may have to use the quadratic formula somewhere along the way, but this is not a quadratic. It's a cubic. So we can't use the quadratic formula when it's a cubic. We can only use the quadratic formula on a quadratic. Nice try, though. So instead, we're going to use synthetic division. I'm going to divide this by something. What to divide it by? You know, I'm going to decide to divide this by some binomial. We could divide it by anything. Maybe you want to divide it by, I don't know, x plus, I don't know, 6. You want to divide it by that? Or maybe you want to divide it by x minus 1/2. You want to do that one? We're going to try to find something that goes into this polynomial evenly. Now, it just so happens I have a magic hat. And my magic hat has binomials in it. And I'm going to pick a binomial out of my magic hat that's going to nicely go in. Here we go. I'm going to pick out of my magic hat a binomial, and let's try this binomial. Can you see it? X minus 3. X minus 3. Let's try that one. There were lots we could have done. There's an infinite number of them. But instead, out of my magic hat, we're going to try x minus 3. Let's see if that works. So again, when I do the synthetic division, remember, right now this one happens to be minus. I'm going to then use a positive 3 over here just because the sign changes. So if that had been a positive 3, this would be a minus 3. Then I use the coefficients. 1, negative 6, negative 1, 30. You don't have a magic hat at your house? You don't go around looking cool with your magic hat on all the time? I'm going to help you learn to make one here in just a little bit. You don't go around tap dancing with a magic hat? I'll teach you how to make one here in a minute. All right, so I'm going to drop down that first one. This direction I'm multiplying. This direction I'm adding. That direction I'm multiplying. This direction I'm adding. That direction I'm multiplying. This direction I'm adding. Hey, look, it really did work. So that really is a factor. You never knew you needed a magic hat? Oh my gosh, how does your house get clean without your magic hat? Yay, we got a 0, so that means there's no remainder. That means that I'm going to have an X-intercept at 3, 0. It means that this is a factor. So I can factor this, which is what I wanted to do. I wanted to F it. So let's factor that. I'm going to make 0 equals, well, x minus 3, and then my quotient is the thing I'm multiplying times. So you remember, go down 1 degree, count down, count down. So I've got x squared minus 3x minus 10. I don't have it down to linear terms yet. So I'm going to factor this also. It's kind of like with that 12, you know, when I say it's 3 and 4, 3 times 4, that's kind of what we have right now. But that 4, it could be factored further into 2 times 2. That's what I'm going to do now, is I'm going to factor this even further. Get it down completely. So, x minus 3, my a is 1, so I can skip straight to the punchline. Austin, if my a is not 1, I cannot skip to the punchline. I have to go through the whole AC method. So if your a is not 1, you can't do what we're about to do. You have to go through that whole AC method. But because my a is 1, then I can say, what are the factors of 10 that add the 3? What are the factors of 10 that add to 3? Let's see. Factors of 10 that add to 3. Did y'all get it? What is it? Factors of 10. So I got 1, negative 10, AC is negative 10. Well, it's 1 and negative 10, or negative 1 and 10. Those don't. 2 and negative 5, or negative 2 and 5. Oh, there it is. There it is. Now, because my a is 1, I can come straight down here. But if that weren't 1, I can't do that. I got to go through the whole method. So we got a plus 2 and x plus 2 and x minus 5. Wait, Austin, I'm going to say that again. We can only jump straight to here because the a is 1. So if your a is not 1, you can't skip straight to there. You got to rewrite this term. Remember how we rewrote this term? Go through that whole process if your a is not 1. So I think you had a question for me. I think that helps to answer it. Go through that whole process. We may do another one later that'll help you remember. Notice I now have 3. 1, 2, 3 linear terms. You told me that we needed 3 linear terms. Those all equal 0. So either this guy equals 0, or that guy equals 0, or that one equals 0. Solve for each one. So I have 3 X-intercepts. Those are not the X-intercepts. The X-intercepts are 3, 0. -2, 0, and 5, 0, because X-intercepts are points. Okay, the other thing I keep seeing missing on what's turned in is you're not talking to me about multiplicity. You've got to talk to me about the multiplicity. And so I'm going to tell you the multiplicity of all of these is 1. Because they only show up one time. What do I care about that 1? It's great that they're 1. It's good for me to know. I need to know that they're 1. What do I care about that 1? Not what does it tell me, but what do I care about it? Kind of like over here. I had to tell you it was positive. I had to tell you it was odd, and so therefore it does the opposite. What do I care about that 1? What's so great about it? Who cares? What do I care about that 1? What's so important about it? You remember? It is true that it's going to cross the x-axis, but why? How do you know that? It's odd. Good, Austin. What we care about it is it's odd. That's right. Because it is odd. Because it is odd. It crosses. So sometimes you may end up with 3 of them. They're going to match 3 times. 1, 2, 3 times, or 5 times. So just because they match doesn't mean that they'll bounce. If it's an odd number of multiplicity, if that multiplicity is odd, then it crosses. If the multiplicity is even, then it turns around or bounces. So this oddness is what's important. So make sure you talk to me about the multiplicity when you turn stuff in. Okay, now we could graph it. I'm going to trust that you can graph it. You know how to do the graphing. This is the big deal tonight, is that we've got to be able to figure out how to factor it when our methods that we've used before, like grouping, don't work. We're going to have to use the synthetic division. Now I know you're like, Ms. Simpson, in your magic hat, how did you know to pull out an x minus 3? Why didn't you pull out an x minus a half? Or how did you know that the roots were going to be what they were? By the way, one of the ones I tried to pull out was x plus 6. But x plus 6 wasn't a factor. I tried to pull out x minus a half, but look, x minus a half isn't a factor. We could have done that all day long and just tried lots of things. So let me teach you how to narrow it down. Now this magic hat may not give you the right answer every single time, especially because, you know, y'all need to hone your magic. But it at least is going to narrow it down from an infinite number of possibilities to just a few. So let me show you what all was in my magic hat. I happened to pull out the right one, but it turns out that in my hat there were more choices. And so to create our hat, what we are going to do is find all the possible rational roots. So if a polynomial has a rational root, it'll be on this list. And the way we make the list is it's the factors of your constant. And your constant is this back number. So it's the factors of your constant over the factors of the leading coefficient. All those possible combinations. All the possible combinations are going to be our factors. So in my magic hat, x minus 3 was one of them. But the other ones, well, let me look at these factors. 1 and 30. So 1 times 30. Well, let me just go in order. 1 goes in there. 2 goes in there 15 times. 3 goes in there 10 times. 4 does not. 5 goes in there 6 times. Okay, now I've wrapped around. 5 times 6, 3 times 10, 2 times 15, and 1 times 30. But also the negative versions. See what Ms. Jimson said? So also negative 1, and negative 2, and negative 3, and I ran out of room, and negative 5, and negative 6, and negative 10, and negative 15, and negative 30. Because you agree that negative 1 times negative 30 also equals 30. So it's all of those possibilities over the factors of my leading coefficient. Now this time it's just 1. So the factors of 1 are just 1 times 1 and negative 1 times negative 1. And it's all those possible combinations. I know, September, my hat had a lot in it. So it's these combinations. 1 divided by 1, 2 divided by 1, 3 divided by 1, 5 divided by 1, 6 divided by 1, 10 divided by 1, 15 divided by 1, 30 divided by 1, negative 1 divided by 1, negative 2 divided by 1, negative 3 divided by 1, negative 5 divided by 1, negative 6 divided by 1, negative 10 divided by 1, negative 15 divided by 1, negative 30 divided by 1. Now, the other way, 1 divided by negative 1. Oh wait, I already have him on the list. 2 divided by negative 1. Oh, he's already here. 3 divided by 1, negative 1. Oh, so it turns out that I've got them all on there. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible rational roots. In my magic hat, there were 16 of them. But we happened to pull out the right one, and we know that only 3 of them worked. The 3 that worked were 3, negative 2, and a positive 5. These were my X-Intercepts. Those were the 3 that worked. Or the factors were negative 3. So notice the sign changes when I make it into the factors. Minus 5 when it's the factor, and positive 2 when it's the factor. So the X-intercepts are those are the actual roots. But the factors, it changes the sign when in that binomial. Now, you're like, oh my goodness, I know, right? This is why I said when they don't match, we're going to cry. It's because we're going to have to go through and try all 16 until we find one that works. I happened to, out of my magic hat, pick the right one. But what if I had chosen all of these first? Oh my goodness, we could have been here for a while. So all I've done is limit it from an infinite number to just some. And if we try all of them and none of them works, then it means that there's not a rational root. Remember how in the last assignment you had irrational roots? Polynomials don't have to have rational roots. They could have irrational roots. They could even not have any real roots. Their roots could all be complex. They don't have to be real. Now, in our class, we're keeping it real. And your polynomials will all have at least one rational root. There'll be at least one sane one in there. Okay, there'll be at least one rational one. But they wouldn't have to. And this list tells us the possibilities. So if we go through all of them and none of them works, it lets us know that it doesn't have any rational roots. You will have at least one. So if you don't find one, it tells you that you did something wrong. Your math was wrong somewhere in there. Okay, let's practice some more. How was that? Was that fun? Did you enjoy making your magic hat? Whew! Let's do another. And let's just skip straight to the X-Intercepts, because I think you got all the rest of it. So let's try this guy. This looks fun. How about we do 2x to the 4th plus 7x cubed plus 11x, no, I lied, minus 4x squared minus 27x minus 18. And we're going to skip straight to the X-intercepts. I mean, we can look at it, we go, well, it's positive, rises right, even, so it's going to be the same, it's going to rise left, it's going to have 3 terms, 4 roots, and that's what it looks like. My Y-intercept is down here at 0, negative 18. Y'all did it, boom. Okay, now we're going to skip straight to the X-intercepts. And look at it. It's got 1, 2, 3, 4, 5 terms. We haven't learned any strategies for factoring something with 5 terms. We only did 4 terms and we grouped it. This one has 5 terms. We haven't learned any factoring strategies for that. So we know going into it we're going to have to use the synthetic division to help us factor it. And when we get ready to use the synthetic division, we're going to need a magic hat. So let's create our magic hat. So we take the factors of our constant. Otherwise, we're going to have an infinite number. I don't want an infinite number. So instead, we're going to do, make our magic hat. So we're going to start with the factors of 18, negative 18. What are those? Like 1 goes in there. 2 times 9. 3 times 6. 4 doesn't. 5 doesn't. 6, oh, I'm wrapped around, so that means it's 2 times 9, 1 times 18. But I actually am trying to get to a negative, so I really need a 1 times a negative 18, and a 2 times a negative 9, and a 3 times a negative 6, so I need those negative versions also. Oh yeah, Jimson says, hey, let's just try dividing. How about we divide by x plus that number? There's an infinite number of possibilities until we make our magic hat. So maybe we should make the magic hat. And we know that only 4 of them, you're right, September, only 4 of these guys are going to work. That's it. The question is which 4, and we're not done because that's the factors of our constant. We got to put it over the factors of our leading coefficient. And this time, my leading coefficient is 1, so is 2. So I have 1 times 2, but I also have negative 1 times negative 2. And it's all the combinations of those. So in other words, 1 divided by 1 is a possibility. 2 divided by 1 is a possibility. 3 divided by 1, 6 divided by 1, 9 divided by 1, 18 divided by 1, negative 1 divided by 1, negative 2 divided by 1, negative 3 divided by 1, negative 6 divided by 1, negative 9 divided by 1, negative 18 divided by 1. Whew! That's not all though, because now I've got to do 1 divided by 2. And 2 divided by 2. Oh wait, 2 divided by 2 is just 1. So I already have that one on the list. Thank goodness. 3 divided by 2 is not on the list. 6 divided by 2, well, 6 divided by 2 is just 3. He's already on the list. I don't have to write him again. He's there. 9 divided by 2 is not on my list. 18 divided by 2 is 9. Oh, he's already there. Negative 1 divided by 2 is not up here. Negative 2 divided by 2, oh, that's here. Negative 3 divided by 2, not there. Negative 6 divided by 2 is a negative 3. He's there. 6 divided by, oh, I did that one. 9 divided by 2. 18, negative 18 divided by 2. Oh, that one's there. So we've done that. Now I'm going to do this one. 1 divided by negative 1. Oh, that's there. 2 divided by negative 1. 3 divided by negative 1. 6 divided by negative 1. 9 divided by negative 1. Oh, I think all of those are there. Thank goodness. Whew. What about this negative 2? 1 divided by negative 2. Oh, yeah. 2 divided by negative 2. Oh, yeah. 3 divided by negative 2. Oh, yeah. 6 divided by negative 2. Okay. So I think if we go through, we now have them all. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 possible rational roots. What is the max number of those that will work? What's the most of those that will work? How many, what's the maximum number of those guys that's going to work? There's 18 that we can try. What's the maximum number of them that will work? Somebody should turn the air on in this school. It's hot. Have to open some windows or something. It's all these people in the classroom. What's the maximum number of those 18 that can work? Yeah, that's right. 4 is the maximum number because there's 4 possible, those are 4 roots. What's the minimum number that can work? What's the smallest number of these guys that can work? What's the minimum number that can work? And then answer Jimson's question. What's the minimum number, and then which one do you want to test? Thomas is technically correct that 1 is the minimum because I told you we're going to have 1 rational. But technically, really, 0 of them could work. None of them could work at all. Not a single one could work. That's right. The minimum is 0. But you're right. I told you at least one of them's going to work. But just know that in the real world, polynomials don't have to have any rational roots. They could be all irrational. Hey, Cherish. So, but you're right. At least one of them is going to work. Now, which one do you want to try? Which one do you want to start with? You reach into your magic hat, and which one do you pull out? What do you think? Which one do you want to try? Yeah, it's true, it's true, it's true, it's true. I did say that. But in the real world, 0 would work. You want to try 9? Okay, I'll try 9. This 9? All right, let's try 9. I like it. So remember, if I'm trying 9, I'm dividing by x minus 9. So the root would be 9, 0, but this one says, but then the factor then would be x minus 9. See how those are 2 different things? When I divide, I'm going to divide by 9. But the factor would be x minus 9. Then, here we go, I'm going to go through and write down my coefficients. 2, 7, negative 4, negative 27, negative 18. Then, I drop that 2, multiply, add, multiply. 9 times 20 is 180. 9 times 5 is 45, so that's 225, I think. Wait, is that right? Let's see. 9 25s. Well, that's 100. 100. 225. So 221. Oh my God, I got to multiply that. That looks crazy. I can do it though. 9, that's 18, carrier 1, 18, 19. Then you add this way. I got 2, 6, 1, 9. Oh my gosh. You think I'm going to make it to 0 here? Is this going to work? I don't know. What do you think? That looks pretty big. I think maybe I could quit, but I want to make a point. So this is 18, carrier 1. That's 54, 55, carrier 5. That's 81, 86, carrier 8. That's 9 is 1, 7, 17,658. I don't think this one's going to work. Subtract, subtract. No, that one didn't factor in, did it? I had a remainder. So this is not a factor. But I did find some good information. Here's what I found out. I found out when x is 9, my y value is 17,640. Crazy, right? We learned something. We know this is our x and this is our y. So on this polynomial, when I'm graphing it, I know that there's a point at 9, 17,640. Hey, that's a point on the graph. I now know something about it. We learned something. Yay! It wasn't what we wanted to learn, but it's something. My graph paper doesn't go up that high either, but I get this idea that it's going to go way up there at that spot. Let's try something different. I think Rachel said another number. What did Rachel, I think she said -3 maybe? Or maybe negative 9/2. Okay, cool. Let's try negative 9/2. That sounds fun. Y'all want to try that one next? So if I'm doing negative 9/2, remember, by the way, this one didn't work. I can get rid of him. He's not a possible rational root. Okay, let's try this one. We said negative 9/2. That sounds fun. Let's try it. So that would be x minus 9/2. Sounds fun. Let's do it. Let's do it. In which case, I'm doing 9/2, which is positive, because the sign's there. This sign, oops, never mind. This sign matches this one, and it changes here. Did y'all catch that? I messed it up. So that matches this, and your factor has the opposite sign. And now I write down my coefficients. 2, 7, -4, -27, -18. Drop down my first one. Don't freak out. You're multiplying by this negative 9/2. So think about it off to the side, 9 halves times 2. You're just going to really divide by that 2 and then multiply by 9. Right? Because we multiply straight across, but we could just divide by 2 and multiply by 9. So we could just make that, this divided by that gives me 1 times negative 9 is a negative 9. Now, add that and you get negative 2. I'm going to do that same thing again. 2 goes into negative 2 one time, negative 1 times a negative 9 makes that a positive 9. Add that. Oh, that one's not as pretty because 2 doesn't go in there nicely. 2 doesn't go in there. So now I'm going to multiply straight across. Remember when I'm doing it, 2 doesn't go in there now, so now I'm just going to multiply straight across. So I end up with negative 45 halves. Yuck. That's okay. We can do this. We know how to do it. You just need a common denominator here. So my common denominator is going to be a 2 on the bottom. Multiply the top by 2, and you have 54. So this is the same thing as 54 halves. I know, that one didn't turn out to be pretty. Subtract, and I've got negative 9 halves. Yuck. Multiply, remember multiply the top times the top, the bottom times the bottom, and I end up with a positive 81/4. Is that going to make 0? Okay, that one's no good. So we'll X that one off. You want to try 3? Okay, let's do it. By the way, if we added that, we would find another point on our graph. It would give us some information. How about instead of this 3, I'm going to try that 3, just for funsies. I kind of think Rachel in the earlier said, let's try negative 3. I'm going to try that one. You're right, we could try this one. I'm going to try that one. So that, let's try plus 3 here. I'm going to assume that's what September means. Let's try a plus 3 there. All right, so let's try it. So a negative 3 there. My magical hat's better than his magical hat. He doesn't look nearly as clever in here as I do in mine. That'll teach you wisdom. That'll teach you, Rachel. You only listen to Pimpson, not Jimson. Unless you're in his class, then he's right. Okay, so now here I go. I'm going to write down my coefficients. 2, 7, negative 4, negative 27, negative 18. Drop, multiply, add, multiply, add, multiply, add, multiply. Hey! Check that out. And you can see why we get so happy. What? Because otherwise we might could have gone through all of these guys to maybe find it. Whew! So we factored it. Yay! We now know that x plus 3 is a factor. By the way, when we're finding the x-intercepts, it's 0, our y equals 0. So we're factoring it. We got x plus 3. The quotient goes here. So this is x cubed plus, we're counting down, x, no x. So now I factored it to this. for my x-intercepts. I found one of them. I know that one of them is at negative 3, 0. Yay! I need 4. I found 1. I need 3 more. So I still need to get this one down to linear factors. It's not completely factored yet. So there are 4 terms, 1, 2, 3, 4. Usually we group. Let's try grouping and see if it works. That's right, Rachel, you trust your gut. Let's see how well that works for you tonight. It'll be all right, you can do it. All right, your x squared comes out. Leaves you with 2x plus 1. Out of the back one, the only thing they have in common is a minus 1. Leaves me with 7x plus 6. They don't work. Look, they don't match. Grouping doesn't work. We break into tears. No, we don't cry because we know what to do. We know how to factor it. We know all we have to do is use our synthetic division and we can divide it. Now, good news is we have the list of possible rational roots already made. It's going to be one of these guys. And we already know that it's not 9. And we already know that it's not negative 9/2. We've already knocked them off. Now, the bad news is it could be negative 3 again. Because remember how we had those double roots or even triple roots? This one could be it over and over and over again. It might be the only one of these that works. So, and I just told you that 1 for sure is going to work. So maybe it just has that same root over and over and over again. So what do you want to try? There are now 16 possibilities up there for us to try. Which one do you want to try? How about I pick this time? How about I pick something like, let's do a fun one. Let's do this one. That one looks fun. You want to try that one? Okay, so I'm going to divide it by x plus 3/2. We could try that negative 3 again. I'm going to divide, though, by x plus 3/2. Now, when I get ready to do it, I'm dividing this one. I like Rachel's 2 too. 2 might work. I'm going to try this one. We're going to use this one. We're factoring this one, but we're just using those same roots. So here I've got a negative 3/2. So I do 2, 1, negative 7, and negative 6. Notice I'm using the coefficients from this. I didn't go back to my original because I'm trying to factor that. Okay, so drop this down, 2. Divide, 2 goes into 2 one time, times a negative 3 gives me a negative 3. I thought, Rachel, we need to practice with doing it with the fractions, just in case you have 1 or 2 of these tonight where the fraction's the only one. That could happen because you know I'm your teacher. So now, negative 2. Divide by negative 2 divided by 2 is negative 1 times a negative 3 gives me a positive 3. Add and you get a negative 4. 2 goes in there, negative 2 times. Negative 2 times a negative 3 gives you a positive 6. Hey, add, yay! We got a 0. It did work out. So that means that this is a factor. So what do we have so far? We know that x plus 3 is a factor. We know that x plus 3 halves is a factor. And we know that this is a factor. So 2 come down 1 degree. So 2x squared minus 2x minus 4. Now what? Now what? I think now we're down to 1, 2, 3 terms. We can either use the AC method, or because this is a quadratic and we're really solving for x, we could use the quadratic formula to find our x-intercepts. But I think the factoring is going to work. Like, I think maybe our AC method will work. But if not, you could use your quadratic formula because you're down to a quadratic. Once I get down to quadratics, I can use my quadratic formula. I also see a GCF, and yes, we can F this. So my GCF in there, I see a 2. Do y'all see a 2 in there? So I've got 0 equals, I'm going to factor out that 2 first. And it leaves me with an x plus 3. An x plus 3 halves. And when I factor out the 2, I've got an x squared, an x, divide that by 2 and you got a 2. See how this multiplies to that? Now we can use our AC method. Our A here is 1. We like it when A is 1. Our C is a negative 2. Our AC is a negative 2. Factors of negative 2 that add up to be negative 1. So we have now factored this. X plus 1, x minus 2. So it turns out that Rachel's 2 that she said would have produced a 0 also. If I had just listened to Rachel, we could have used 2 over there instead of that crazy fraction. Also, 1 would have worked. So this one would have worked, or that one would have worked. But this one wouldn't have, that 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 one, that one, that one, that one. Holy cow. Whew. So those 4 that were in our magical hat worked. All right, I'm going to get rid of those and let's finish. So the x-intercepts here, I'm not quite done. Set each one of those equal to 0 and solve. By the way, this 2, you can get rid of the 2 just by dividing both sides by 2. But my x-intercepts are going to be a negative 3, 0, negative 3 halves, 0, negative 1, 0, and 2, 0. The multiplicity of each of those is 1. We care about that multiplicity that it is odd. Oddness tells me it crosses. So multiplicity. Be sure and tell me about that. And then tell me what you care about that. The fact that they are all odd. And so therefore it crosses. Don't leave that off. Don't leave that off. All right, I'm going to do one more. What do you think about your magic hats? Y'all got cute little magic hats? Let's see what's on my magic hat. Look. There's a cute little key. Look, there's a key to mathematics right there. There's a key to everything. There's a little bird. See the little bird? Little bird. My magic hat. Lots of gears. Plus my floor gets all glittery. All right, one more. Let's do this guy. Thanks. Y'all don't like these? Come on, guys. Magic hats are cool. All right, we're going to skip straight to the X-Intercepts. So, I know that my y equals 0. I tried grouping, it didn't work. Darn it. So I'm going to use my possible rational roots. First thing I got to do is make my hat. Factors of my constant. 1, 2, 3, 4. 5 didn't go in there. 6. Oh good. 4 times 6. 3 times 8. 2 times 12. 1 times 24, and I know it's the positives and the negatives. Oh, good eye, Austin, good eye, good eye. Now the factors of my leading coefficient, which is 1, and the negative. And all the possible different roots. Or you can just go, look, these guys divided by those guys, and it's all the positives and negatives. So I got a little lazy here. Instead of writing them all out, I'm just saying, hey, it's all of these guys. The positives and the negatives of those combinations. Now, I am going to tell you what they all are. Do the division. So we got 1, 2, 3, 4, 6, 8, 12, and 24. But it's those guys, positive and negative. So how many are there? I got to open a door or something. I'm dying in here. So how many possible rational roots are there? How many PRRs? Nobody's answering. Everybody went away. Everybody left me. They went to open the doors and windows also. Got hot all of a sudden. Motorcycles passing by. 1, 2, 3, 4, 5, 6, 7, 8. But that's just these guys. What about those guys? Ah, that's right. There are 16 possibles. Because it's the positives and the negatives. So the minute I didn't write them all out, don't forget there are positives, but there are also negatives sitting there as well. It's both. So don't forget about, if you're going to get lazy and write it positive and negative, then make sure, and on my paper that you turn in, the quiz that you turn in, you better just write all 16 of them down. Don't get lazy like that. Don't be lazy. Don't be lazy. Don't be lazy. That way you don't forget. You tell me how many there are. Which one do you want to try? Which one do you think? What shall we try? Two. Rachel says let's divide by 2. She says let's use this one. Did I do this one in the video? I wonder. Did I do these in the video? Let's try 2. So that I'm dividing by x minus 2. Either that or Rachel's already figured out this magic hat thing. She's got it down. It's pretty impressive. Definitely want to start at those easy numbers. Most of the time you want to start at 1, and then maybe 2, and then maybe 3. You know, always start low and build up. Wow, you're getting good at this magic hat then. I'm really impressed with how fast you made your magic hat. Drawing out the magic ones. I don't know that I did this one in the videos. Okay, but Austin noticed something. When I get ready to do this synthetic division, there is something missing. So I'm writing down my coefficients. 1, and Austin said, hey, where's that x cubed term? So I have to put down, in place of that x cubed, a 0. There's that x cubed term. And then I can keep going. Negative 18 is the squared, so to the 4th cubed squared, let me use black, I can't quite see that. So 1, 0, negative 18, 40, and negative 24. Yeah, be sure and put that placeholder down. Then I'm going to divide by 2. So 1, multiply, 2, add, multiply, add, multiply, add, multiply. Uh-oh, that didn't work. Wait, did I do the wrong? Yeah. 40 minus 28 is a positive 12. So that's a positive 12. Oh, thank goodness. Yay! So 2, 0 is going to be an X-intercept. And I factored it. I now have 0 equals x minus 2 times, this goes down 1 degree, x cubed plus 2x squared minus 14x plus 12. We get to do it again because I'm down to x cubed, but there's still going to be a total of 4 roots. So we're going to try again. And again, when I do it, this time I'm using this. And it could be any of those 16 possible rational roots because we haven't tried any, we haven't eliminated any. Now I'm going to cut to the chase and I'm going to use Rachel's again just to see if it works. Because remember that it could work again. Maybe it's 1, maybe it's 3, maybe it's 4, maybe it's 6, but this 2 could work again. So I'm going to do it again. I'm going to divide again by x minus 2. And let's just see if it does work again. So I'm going to take this and divide into this guy. So 1, 2, negative 14, 12. So notice again, I'm not going back up to here. I know, right, Austin? I'm not going back up to there. I'm just from here. Drop it down. 1, multiply 4. No, that's a 2. 2, add 4, multiply 8, add negative 6, multiply negative 12. So what does that mean? It worked again. That means that this 2, 0 shows up twice. It's a double root. I have now factored this thing. The first time we divided by x minus 2 and it worked. The second time when I took my quotient and divided it by x minus 2, that means that this thing factored with an x minus 2. So x minus 2 times this quotient, x minus 2 times this thing, x squared plus 4x minus 6. This times that gives me this. X squared plus 4x minus 6. This times this times this gives me that. Yes, Austin, you're right. I could write it as x minus 2 squared. I'm going to leave it like this, though, because I want it in those linear terms so that I can see each one of my x-intercepts. Now, I'm going to use my AC method to factor this guy. So my A is 1. My C is negative 6. My AC is negative 6. Factors of negative 6 that add up to be 4. So let's see, 1 and 6, 2 and 3. Which one of those is going to work? Which one of those works? What you think? What should we do? What to do? Anybody there? Tell me what to do. Oh no, none of them work. So what are we going to do? Since none of these work, I can't factor this using the AC method. We are going to cry. No, you've got a strategy. Remember, this is a quadratic. This is a quadratic. So what do we do to find out what x equals when we have a quadratic? By the way, since AC method doesn't work, none of the rational roots are going to work. These were the only possible rationals for this guy. They didn't work. So therefore we aren't going to be able to. That's right, let's sing a song. You got it. We get to sing a song. We get to use the quadratic formula. We go, x equals negative b plus or minus the square root of b squared minus 4ac up over 2a. Yay! So, we go x equals, well, negative b squared 4ac all over 2a. So, negative 4 plus or minus 16, and negative times negative is going to make that a positive. 4 times 6 is 24 all over 2. So I have negative 4 plus or minus the square root of 16 plus 24 over 2. That adds up to be 30, 40. So I got the square root of 40 over 2. 40 breaks down to 4 times 10. The square root of 4 is 2. So this is negative 4 plus or minus. This is 4 times 10. But the square root of 4 is 2. 10's not pretty. Negative 4 divided by 2. 2 divided by 2. So I've got negative 2 plus the square root of 10 and negative 2 minus the square root of 10. 2. Yeah, I know, it doesn't do very well. I don't know why on the edges you can't see it very well. But use your quadratic formula, and you end up with x equals negative 2 plus or minus the square root of 10. I never can figure out why the camera won't let me, why it blurs on the sides. So, how does it factor? Well, it looks like this. X minus 2, x minus 2. If you're looking at factoring it, it's x plus this 2 plus the square root of 10, and x plus 2 minus the square root of 10. That's crazy. Or your x-intercepts are just at 2, 0, 2, 0, negative 2 plus the square root of 10, comma 0, and negative 2 minus 10, comma 0. So that answer down there, negative 2 plus or minus the square root of 10, well, negative 2 plus the square root of 10, 0, and negative 2 minus square root of 10, 0. Those two are your two x-intercepts. Notice out of those 18 possible rational roots we had, remember there were 18, were there 18 of them? Or 16, however many there were. Out of all of those, only one rational root worked. Only 2 worked out of all of those possibilities in the beginning. 16, out of 16 possibilities, only one of them worked. The multiplicity here. This guy shows up 2 times. This one shows up once. That one shows up once. We care about this, the fact that it is even. These guys are both odd. That evenness tells me it's going to turn there. This oddness tells me it's going to cross at both of those. Be sure to include your multiplicity. Yeah. Only one actually worked out of the 16. Isn't that crazy? Because those 2 are not rational. They're irrational. That's right, Rachel. When it's an even multiplicity, so if you have 2 or 4 or 6, if it shows up 2 times or 4 times or 6 times, it's going to turn at that point. But if it shows up an odd number of times, in other words, 1 time or 3 times or 5 times, then it crosses at that point. So multiplicity, what we care about this is the fact that it's even. What we care about that is the fact that it's odd. That's what tells us what's happening. You got it. All right, your job. Do your homework. Make me a video. Turn in some quizzes. Make me a video. Make it good enough. Practice maybe a couple of times and then make the video. Turn it in. Link it on the Dropbox. Give me your link. Make sure when you make your YouTube video that you say no to children. You're not making this for children. And make sure your comments are on so I can comment on it. And make it good so I can share it on our page. That's what I want. That's what you're going to do. That's right. That's what we do is we share it around, and y'all have to. They decide Who passes and who fails? So make the video good. You just think you're about to get your A in the class. All right, and I'll see you on Discord. I'll be there. So, Math Made Simple at Simpson Math. Thanks for watching. I'll see you on Discord. That's what he says. He's like, fail them. Don't let them in my pre-calc class. Now, usually he watches and he's like, I want that kid. Give him to me. Tell him to take pre-calc. Sign him up right now. That's what he says about all my students, because my students are the best. No, you can do it, Rachel. You can do it. You can do it. You can do it. Become a movie star. We'll make you famous. Maybe you'll go viral. If I can't go viral, none of y'all are going viral. Trust me on this. I've tried for years. It doesn't happen. All right, see y'all on Discord. GN.